Okay, let this render. Perfect. So who am I? As Anna said before, I am David. I work in NearForm for almost 4 years now. I'm also part-time lecturing at CCT College. By the way, some of my students are here, so better start studying because you have an exam on Friday. I am also a Google Developer Expert on Kubernetes, which is a nomination that Google gives to some individuals on the community. And I am a Node.js Foundation member on the security working group, which I am not very active lately because life has gotten suddenly very busy. And well, I also wrote these 2 books. The first one is quite old. It's almost like 5 years. The second one, it's old. It's only 3 years. And you know that 3 years in IT is like a whole world. So what am I going to talk today? So I'm going to talk about mainly what's going on in the world on every single company. So this is what you will recognize on your everyday work. So you have your application, which runs in a runtime, runs in a container runtime, and you might have noticed that I have mentioned that application runtime and container runtime are completely technology agnostic, and then somehow they end up running in Kubernetes. Okay. But we use Docker Swarm at work. No, you will use Kubernetes. In the next 2 years, I think it's going to eat the world if it hasn't eaten yet. And to be honest, like many of the serverless platforms today run on Kubernetes. So you better start learning how it works. So traditionally, this is what we are looking into. And this is what companies who are starting to do DevOps are looking into. So the developer territory, which is pretty much, the application and runtime. Developers write applications and they deploy them in a runtime, which is Node.js, which then where the application is going to be deployed, nobody cares because we are developers. And then we have the DevOps, which is a poorly named use for someone who is looking into the container runtime and Kubernetes. My idea of DevOps, it's completely the opposite of this, okay? But we are going to talk about this in a second, and I'm going to demonstrate you with code why this is a bad idea. Okay, so briefly, when you have this situation, everybody is like, yeah, we are DevOps now, everything works fine. But then 2 months into this, and this is what you see every day in your company. So you have your DevOps team in one side talking about, platform, not knowing what even the applications are running on the platform. Developers, which are completely careless about where the application is running. That doesn't really work, okay? That is when you end up in a very siloed company, which is the last thing you want to be. An application which is siloed, which has the tools to break production in 2 clicks. We don't want to be there, okay? So what causes these fires? So at the moment, there are 3 cases. The first one is the developers, as I said before, and it's not in order or importance, okay? They are equally important, all of them. So they don't understand where the applications are running. It's not the same running an application on an EC2 instance in AWS than what it is running the same application in a container in Kubernetes. First of all, your application in EC2 is going to have access to swap memory, so it can overrun your memory. Whereas on Kubernetes, that doesn't happen, and you need to do something about that. DevOps engineers not understanding the application. So I know a huge amount of DevOps engineers which are incapable of coding, which is fine, but we should have a better term for that because that is not development and operations. That is just someone who understands very well code and understands very well the underlying technology, but we should probably spawn a new term for that. And then poor alignment in management with engineering practice. I mean, that is very common symptom of a much deeper disease, which is companies not running efficiently. So this leads into, I am sure all of you are familiar with this chapter of The Simpsons. I don't know about you, but I have seen Simpsons so many times that I can replay the chapters on my mind without a TV. So yeah. And the phrase below this picture is something I really got told possibly like 5 or 6 years ago. We're a team of high performers because we do things our way. Okay, so this is the famous last words of a company. You should not ever do things your way. You should do things the standard way. Okay, never get into, oh, we are going to build a very complicated way of deploying software, because then you hire a new engineer, and what happens? Like, obviously that engineer is going to suffer a lot to get there. My advice is embrace your platform always. Nobody buys a BMW to drive it like a Renault, okay? When you buy a nice car, you want to use the nice car. So vendor lock-in, everybody is like, we should not vendor lock-in because we might switch provider in 2 years. That is not true. I have not ever seen anyone switching from one vendor into another successfully. You should embrace your vendor, and I'm not promoting AWS or Google Cloud Platform or anything. But like trying to avoid the vendor lock-in is like trying to avoid the gravity by jumping. You don't, okay? So you just briefly believe that you are getting there, but you don't. Your application needs to be tied to the platform to work efficiently. So I've seen people who does not want to use certain capabilities on AWS because they are not present on GCP or they don't have any equivalent, and that's just wrong. It's plain wrong, okay? You should embrace the platform and you should use it as much as possible. Kubernetes everywhere. So Kubernetes is the way to go. When somebody approaches to me saying, oh, we want to deploy my application, but we are thinking on EC2 instances, I just stop there and say, no, think again, and then we talk. Not because Kubernetes is well implemented or not because Kubernetes is whatever you want to be. It's because Kubernetes provides a domain-specific language, a DSL, that basically gives you the common points between development and operations. One of the things that I stress a lot into the development teams which I work with is your application should be done better. Okay, you should not try to be smart in your application or at your application level. Your application is going to be running in a platform, which in this case, or in my case, is Kubernetes. And Kubernetes itself has a factory of runtime patterns. Okay, so you need to use them. You are not going to, buy a BMW with heated seats and then bring your hot water bottle because you already have that in your car. So you really don't want to reinvent the wheel. Configuration, okay? So the configuration is usually a pain, and I've seen many imaginative ways of injecting the configuration on applications, like reading a file from a certain location, reading a file from storage. Don't do that. I mean, your application should receive the configuration via environment variables, and where this configuration is coming from, nobody cares. Your application just reads environment variables and processes them. That's it. You should not go fetching your configuration from HashiCorp Vault or from a parameter store in AWS or something like that. Just trust your development environment, and then it will be fine. This is the BSD philosophy. Okay, do one thing and do it well. I think Anna already mentioned that on her talk about pulling modules out of Node Core and making a smaller Node code that does things well. I'm totally up for that, and I subscribe what Anna said. It's a pattern I've seen many times, trying to outsmart the world. That never works. Error management, super important. Non-recoverable errors should kill your application and let the platform bring it back to life. That's, again, the don't get smart and do things right, okay? Let's say you are trying to connect to a database, and then you get a wrong password. What do? Like, I've seen logic to try to retry the connection. You shouldn't do that. I mean, a wrong password means that something has happened, somebody has changed the credentials, the database is having trouble, or your application is not doing things correctly. So what you do in that situation is just kill your application, let it finish, and then Kubernetes will bring, hopefully, the new version of your application, which will have fixed this problem, or it will fix the configuration. The next one is capture all the metrics. You should capture absolutely everything, from the memory to CPU, how many GET requests do we have, how long was the duration of them. And then what you do is you alert in a subset of this communication, of these metrics. You should not be alerting on everything, because then what you have is a disease which is called excess of alerting. Okay, so that's when you have engineers which gets 20 pager duty alerts in a day in their phone, and then all of them get ignored. And what happens is your platform is actually down, and you stop getting alerts, and everybody's like, well, that resolved itself. And it happened to me in the past, by the way. And then listen to the signals. That was going to be some sort of transcendental spiritual thing, but that's the reality. Your platform is going to be sending you signals, like proper unique signals. You should be interacting with them. Otherwise, what's going to happen is you are going to be in deep trouble with transactions. And if you're working in a highly transactional environment or in finance, you might know that losing 2 transactions a day, it's a big problem, and big problem enough to get in trouble with the central bank. And then I have put observability 3 times here because it doesn't matter how much I repeat it, I still get log lines saying error 500, internal error, and that's about it. So you need to be able to observe your application, how much memory is being used, how much CPU is being used, the log of your application. If you want to expose other metrics, fine, but you need to be able to, in one single dashboard, with one click, be able to see what's going on in your system. And that is kind of like, the holy grail of DevOps, being able to react fast into things that are broken. Okay, so I have talked a lot, and I'm a man of action. I'm sort of DevOps. So what I'm going to do now is I'm going to reopen all the windows that I had open prepared for the presentation, and hopefully nothing is going to fail. Okay, so I have one application here. This application is a simple Fastify application, okay? And this Fastify application means that, well, we have one handler, which is just a simple hello world. And then we have another one, which is a bit more problematic. This is the typical memory leak in your application, okay? This is the most dreaded situation when you are working with software. A memory leak which you can't find where it is and keeps killing your servers. That's proper bad, okay? I've been, in the past, before Kubernetes, mining a server during holidays, restarting it every 8 hours because we had a memory leak which we couldn't find, and I had to log in, restart the server in order to prevent bad things to happen. And that's bad, okay? Then what we do is we start the application, and we have a server, okay? That will work perfectly. By the way, can you read my fonts? I guess so, right? But let me just check the chat. Is it possible to increase the font size? Yes, it is possible. Okay. Is it better now? I think so, right? Better? Yes? Okay, if not, just stop me, okay? Because I cannot increase it too much, otherwise we are not going to see the code. So the first thing that we talk on this talk is we need to inject the configuration via environment variables. This is a very common situation. Your server is listening into one port, into one interface. This means I'm listening into all the possible interfaces. You don't want that, okay? You want to listen to the interface that is going to give you access to the network that you want. Okay, 1 second, let me see. Okay, so fonts. Perfect. And then the port is something that is not a big deal if it is fixed, but what we are going to do is we are going to inject the configuration via environment variables. One advice, use a library, okay? Never go into process.env and trust that things are going to be there. In this case, I'm using something called convict from Mozilla. And what I'm doing is I'm defining my configuration and a default value. Okay, so this default value is going to be 3000 for the port. And then the IP, we're going to listen to everything. Read the configuration from a file, so I can override it from a file if I want to. And then validate it, because I don't want to start my application if the configuration is incorrect. So that will be something bad. Okay. So what we do is we import the configuration. And now what we do is we override the port. And we override the IP address. I think it was like this. IP is not IP address. Okay. So this is magic because my application is doing the exact same as it was doing, but now this data is being injected via environment variables. So I can show you that fairly easy. So npm start, and that will listen. Oh, something is broken. Oh, of course, my fat fingers Gonzalez. So we start the application. We are listening on the port 3000. And now what we do is we stop this port 3001, and my application is listening on the port 3001. And that is as simple as that, okay? So that is the first thing that we should be doing. The second thing is listen to signals, okay? So my application has a server. This server might contain some long-running processes. So if I shut down the application, I am not sure if my server is already processing something or not, okay? So what we need to do is we need to make sure that the server stops reading, stops getting requests, and then we want to gracefully shut down the application itself. So we are going to create a new file. We're going to call it signals.js. Exports. We create a new function here. And this new function receives a parameter, which is a Fastify server. And then what we do is process.on sigterm. Now we do fastify.close. Okay, this receives another callback, which log info. Okay, uppercase Fastify because it's an amazing framework and so much respect to it. Okay, so now what we do is we run this application, and now you can see how this font is probably too small. I think that one is better. How when we press Ctrl+C, we actually don't get any logging here because Ctrl+C sends the sig int, not the sig term. Okay. And for some reason, it's not getting the, oh yeah, of course. Because now what we need to do is we need to go here, import the signals. Now, once we have Fastify, what we do is, actually we can do it here. And I think this is going to work as it is. Okay. Now we need to process the sig int. Okay, and you can see now how once we press Ctrl+C, we are sending sig int into Fastify, and we execute the code associated to it. So the first one will be, we are closing Fastify. So we are letting the Fastify to close the connections, and then we close it. When we are in the containers world, or in Kubernetes world, we won't process sig int because it's an interactive signal. We will process sig term, which is what Kubernetes does, and I will show you in a second. Okay, so that is the second problem. And now the third problem usually comes here in the Docker file, okay? Two problems here. The first one is your process should scale out in the platform, not in your Docker container, okay? So never use anything like nodemon, PM2, or anything like that in your Docker file. Why? Well, because if you use nodemon, your application is constantly crashing, or your application has crashed because something is wrong. The process that your Kubernetes cluster is looking into is nodemon. And what is going to happen is the Kubernetes cluster is going to go like, this is great, everything is working, no problems, which is not, okay? Because your application won't be there. And second, if you are using TypeScript, transpile the code beforehand. Like I've seen some images doing something like ps run, which is basically runtime transpiling for TypeScript. That sends a huge spike of CPU and memory into the cluster. And that's bad because what we tend to do in DevOps to avoid the noisy neighborhood scenario is basically we limit the applications on CPU and memory. So that means your application might well be killed by the TypeScript transpilation. And even more, you might be killing other applications if we are not very careful. So always transpile your TypeScript into Node.js. Okay, so this application now is a bit more DevOps friendly, but now we need the platform to run my application. Okay, I've done something brave. I don't know if this is going to work or not, but I have a Minikube cluster running, and this Minikube cluster, you can see, is completely empty. Okay, it only contains what it comes from Minikube. So what I'm going to do now is I'm going to deploy this application, but I'm not going to just straight deploy the application. Okay, I wrote a Helm chart for it. But even better, what I'm going to do is I'm going to use GitOps. Okay, and that GitOps means that I'm going to have something on the cluster deploying the application to me, reacting to changes on Git. Okay. Before that, let's go through the Helm chart. So this is pretty standard. Okay, nothing is out of normal here. So we have my deployment. I don't know if you are familiar with Kubernetes or not, but this is basically how you deploy an application in Kubernetes. You just define one API resource, which in this case is a deployment. There are like a few hundreds of different resources between the community and Kubernetes. What this is going to do is this is going to keep my application alive with as many replicas as I want. And now we start to see the value and the profit of having a DevOps-friendly application. I can override these values without modifying the code of my application. Why? Well, because this is going to be passed into the environment of my container, and that means it's going to be read by my application, and it's going to be used by the same application. Then another thing we have here is resources. This is very important, okay? That means I am requesting to the cluster 100 millis of CPU and 25 megabytes of memory. But the limits for this application is 200 millis of CPU and as maximum 50 megabytes of memory, okay? That doesn't mean that when we reach 50 megabytes, it's going to be absolutely killed immediately, but means that once we reach the 50 megabytes, the cluster knows that this application is misbehaving, so it will kill it. And usually it's pretty fast, okay? There's one very interesting tag from Kelsey Hightower about this. This is like a Lego block or a Tetris block. If you don't give to your containers or your pods limits and requests, your scheduler does not know how to act on it, okay? This is the same that when you have a shop and somebody comes and says, I want to buy cars. And the first thing you ask is how many cars? And then you can organize the logistics around it. Okay, so we have that. And then what we are doing is in order to be able to access my application, I'm going to expose it via service. And there is nothing crazy here, okay? These are variables. So I render the values here. And now I have values for dev, values for production, values for QA, and all the standard values. So if the value is not found in an environment, it will fall back into the standard values. And for example, that's the case with the port. Okay. Now what I'm going to do is on my cluster, the first thing I'm going to install is monitoring. Monitoring is super important, okay? And many companies and many people will tell you, oh, but it's really hard to maintain, it's really hard to organize, and it's really hard to install. Okay, I'm going to show you how to take the benefit of Helm and Kubernetes to install Prometheus, Alert Manager, and Grafana in one single command. So we go Helm install. So we are going to call this Prometheus operator. And we are going to install a stable Prometheus operator into the namespace Prometheus, which possibly does not exist. So I'm going to create it. Sorry. Okay, and now we can go back into this. Some people will say, well, I don't know what I am installing. I will always say, yes, you do, because if you go to your browser and stable, there's a full repository here with all the things that you can install from the official Helm repository. Okay, so for example, this one, Prometheus operator, is what we are installing. And then you can override values with the configuration here, okay? So you will be able to specify the things that you want to configure and so on. Okay, so render manifest container source already exists. Install. Okay. Oh, something is wrong here. That's fine. We are going to possibly try to force it. And because we are on health tree. So what this is going to do is it's going to, oh, it's the pod security policy. Sorry for that, but that was going to happen always. Okay. Policy, and then we remove this one, remove this one, remove this one. So that's gonna test everything which is Prometheus related. Okay, that should be better now. Let's give it a second. Okay, so we are not going to be fiddling with this because probably it's going to take me some time. So what I'm going to do is I'm going to go straight into Argo CD, and we will come back to that. So this will be monitoring. What I will do usually in my projects is use something called Argo CD. Okay, Argo CD is so 2020 that, I mean, like 3 months ago wasn't even stable, but we are using it quite intensively in NearForm. And what gives us is an easy way to control applications based on GitHub repositories. So in this